So the problem is, suppose the liquid phase decomposition of A takes place according to the following kinetic scheme, with rate loss as indicated. A, the reaction of A is decomposed to B plus E, in which the rate of rate constant, or the rate of reaction, is equals to K1CA, and A decomposes to D plus E, in which RD is equals to K2CA. Reaction is carried out isothermally, so meaning the change of T is 0, so the temperature remains constant. In a batch reactor with only A present initially, A present initially, at concentration CaO is equals to 4 moles per liter in an inert solvent. Inert solvent meaning it will not help, or it doesn't have any effect in the reaction. And at T is equals to 1200 seconds, Ca is equals to 1.2 moles per liter, and Cp is equals to 0.84 moles per liter. Calculate the values of K1 and K2 and the values of Cd, this is D, and Ce at 1200 seconds. So, important things to remember. So, remember that, number 1, the reaction is isothermal. So, delta T is automatically 0. And remember, number 2, only A is present initially. So if we're going to draw this one, this problem, it would probably look like this. We have a batch reactor, and then we have A here, A plus the inert, which doesn't really affect the reaction of A. So the inert here will always stay the same from T equals 0 to T equals some anytime T. And then as time passes by, we can get B plus E, and the rate of this is RB equals K1CA. We can also get another one here, which is the D plus E, which has a rate equation of K2CA. So there we have it. There you go. And then this equation here, or this problem, is an irreversible reaction in parallel. Remember that the irreversible reaction in parallel has a general formula or general equation of negative RA is equals to negative dCA over dt equals K1CA plus K2CA is equals to K1 plus K2CA. So to easily understood where we get this, no, we will remember that there is a ratio, what's this, relationship between RA to RB and RA to RD. So RA, remember that RA, RB, and also RA, RD. So basically, this one is just is having a relationship because of this one here. So going back to this equation here, so we have negative dCA over dt equals K1 plus K2 CA. So I'm combining like terms. We have dCA, CA, K1 plus K2 dt, ln CA, CAO, this is the initial rate, K1 plus K2 T. So this will be the backbone of the solution in our problem. So now we have a clue how to get, remember the question, we are asked to get the values of K1 and K2, K1 and K2. So here you can now get the value of this one. Remember that the given, there's a given, this one, CAO, we have CAO here, CA, and time. So now we can get this one here. So negative ln CA is 1.2 over 4 moles K1 plus K2 1200 seconds. So K1 plus K2 is equals to, let me check the calculator, negative ln divided by 1000. So we have 1.003 times 10 to the negative 3. But we are asked to get the values of K1 and K2. So we can solve this one by using this relationship here, RA and RB, because RA over RB is just equal to 1. So now here, so dCA is over negative dCB is just equal to, what is the R of this one is K1 plus K2 CA, and this one is K1 CA, because remember that here we get the RB from here. So now we have this one. So integrating or just simplifying this one to a more solvable form, CA initials over CB final minus CB initial. Okay, equals K1 plus K2 K1. So these two here will just cancel out each other. Remember that our CA is what? 4 moles from the problem. 4 moles minus this one. We will base here at T is equals to 1200 seconds. So our Ca is 1.2. This is a decomposition problem. What do you think? CB final. Yeah, that's what we're looking. CB final is sorry, there's a value 0.84. This one here, 0.84. So now we have this one. What do you think will be the CB initial? Yeah, right, it's 0. Why? Because remember the important things I've been telling you lately. Only A is present initially, so there is no CB at time cost 0. So K1, we know this one, right? K1 plus K2 is from the previous one here. We need this one now. 1.003 times 10 to the negative 3 over K1. So now we're down to 1 unknown. We can solve this one now. K1 is equals to, you can just check this if you want in the calculator. So I calculated this lately and I got 3.009 times 10 to the negative 4. And since we have this one here, we can now calculate K2. Right? K2. Since we have this, K1 plus K2 equals 1.003 times 10 to the negative 3. K2 is just 1.003 times 10 to the negative 3 minus 3.009 times 10. So K2 is just equal to 7.021 times 10 to the negative 4. Okay, so now we have values of K1 and K2. Letter A, this is now checked. We're done with this one. So now, let me get that paper. Now we will solve this one here. The values of CD and CE at T equals 1200 seconds. So here. So using this one here, so this relationship. Where? This relationship. So I did this. Negative DCA over, is it a negative? Oh yeah, it is DCD equals K1 plus K2 CA K2 CA. So these two will cancel out each other. And then CA initial minus CA final, CD final minus CD initial. K1 and K2 is just equal to 1.003 times 10 to the negative 3. And we now have K2, which is 7.021 from what we have solved lately. This one here, 7.021 times 10 to the negative 4. Wait, yeah, right? I should hope so. 4 moles minus 1.20 over 0.84. No, this is an unknown. Yeah, CD final this will be here is 0 because there is only a at the initial. And then this one here, let's see how 1.003 times 7.021 10 over 7. So solving this one here, we get 1.96 moles. This one mole. This is per minute or seconds rather. S negative 1. This one. So now we have to look for CA. But then I think it can't be solved because we don't have the initial value for this one here, this one, of the inert solution solvent, because actually this E here will just be constant all throughout because it's not included in the reaction, and I think it's not needed, so I didn't solve this one because it will be constant all throughout. That's it. I hope I helped you. Thank you for watching.